latest EMEA webinar. Thank you for joining us. And also thanks to the guys at Cargill Bioindustrial for offering this topic today. I will introduce the speakers in a second, and then I'll also do my best to handle the questions at the end. As Stephanie said, please put those in the chat, and I'll do my best to pull those together where there's similarities or common themes. So, our speakers today. Luca Massetto is a business development manager at Cargill Bioindustrial, who are working to enable a safer, effective and sustainable energy transition roadmap. Luca brings 16 years of energy management experience across multiple industries, geographies and scales of business. He focuses on transformer risk management through educating on the advantages of the adoption of natural ester dielectric fluid in various applications like renewables, industrials, EV chargers, BESS, green hydrogen, data centers, and the like. Luca holds an MSc in mechanical engineering, and he says he is enthusiastic about connecting the dots in the energy business by leveraging his position for creating new authentic connections. There is always a good reason to exchange and share. Now there's an invitation to network that you can't ignore. Roberto Fernandez is a senior electrical engineer who has spent most of his career in the transformer design field, including research and development activities focused on the magneto-electric and thermal design for a wide range of transformer applications. He is a member of the IEE, the CIGRE, and several national and international working groups. He is currently the application leader at Cargill Bioindustrial for dielectric liquids, where he supports OEMs and end users in the transition to a more sustainable and reliable grid. Gentlemen, I'll hand over to you. Thank you again.
Thanks a lot, Patrick. So, as Patrick said, my name is Roberto, and I will be doing the presentation for today. So, our main focus here is just to give a brief introduction about the different types of fluids inside the transformer, how they interact with the risks inherent to this device, and how the adoption of natural esters may help to reduce these risks and also improve the resilience and the reduced failures of the network. So we can see here short agenda that we are going to see today. So we are going to start talking a little bit about the definition of some parameters of different fluids. We will talk how natural esters helps to prevent a fire in the event of a failure in the transformer. What are the impact of the adoption of this fluid in the rest of the installations? We're talking about substations, clearances, and so on. We will address very briefly the retrofill of the transformers, that is basically switching one fluid by other, and which opportunities and benefits this brings to the end user. We'll talk a little bit about sustainability, just a couple of points, just to give you an idea how all this connects with this new trend in sustainability that is very present in the market and important for customers. And we will end with a comparison between the two different technologies, so liquid filled transformers and DryType transformers, and see how they compare side by side, just to give you also an idea about what are the main difference and the main advantages one over the other. As Patrick was saying, we will have a Q&A session at the end, so hopefully we will be able to answer as much as questions as possible. And to start with this, I need to start talking about one specific parameter of the transformer. So we all know that inside the transformer, you have different materials, copper, magnetic steel, paper, different materials. And the main risk, the main point that we need to address is the liquid that is inside the transformer. So when we think about the fires and what is the most critical factor is the fluid, and there is one specific property that it's strictly related and connected with this risk, and is the fire point of the fluid. I just put here the definition of the fire point as it stated on the standard. So it's the lowest temperature at which the vapor of a fuel continues to burn for at least 5 seconds after the ignition by an open flame of a starting dimension. This is basically how the test is done. A small amount of fluid is heated. It starts to generate volatiles and vapors, and you pass a flame over it. If it starts the ignition and the flame lasts at least 5 seconds, this is the fire point of a fluid. I will show some videos later showing how this impacts in the behavior and how the different failures are connected with this parameter. Important values here, just you can see here on the screen, we have a mineral oil with a fire point of 160, synthetic fluids that have a fire point above 300, so around 310, 315. And we have FR3 fluid that is a natural ester, which the fire point is 360, which means it's more than 2 times of the fire point of a mineral oil. I have marked here a red line. This is the definition of a K-class fluid. A K-class fluid is considered a fluid that has a reduced risks in terms of fire ignition and propagation, and is defined as a fluid that the fire point is above 300 degrees. So as you can see here, this is just, there are several fluids that can be compliant with this definition, but we will see how the different values will impact the risk and the effects of a fire. For the ones that are not very familiar with the different liquids that may be inside a liquid field transformer, I made here a comparison side by side, very simple, very high level, between mineral oil, that is the most common, most used dielectric fluid inside a transformer, and a natural ester like FR3. So first difference is the base fluid. Mineral oil comes is a petroleum oil, and a natural ester comes from a vegetable oil. So it means that it comes from a renewable and a source and a natural source. If we go to a comparison, talking about dielectric capacity, which is important for any electrical device, and we take mineral oil as the reference one, the properties of the natural esters, FR3 in this case, it's equivalent to mineral oil with some advantages when we talk about specific property that is the partial discharges. So it's important, of course, the cooling performance, and in this case, natural esters has a higher viscosity, but at the same time has a higher heat transfer, meaning that the oil flow inside the transformer will be slower, but the ability to remove heat will be higher. And these properties, depending on the design of the transformer, will somehow balance and will have a very low difference in the final results. Fire point, we spoke, 160 for mineral oil, 360 for natural esters. So it's a gap of 200 degrees. Of course, if the raw material is a natural oil, a vegetable oil, or natural ester, it's a fluid that is ultimately, but also really biodegradable. Opposite to that, mineral oil is a quite a stable molecule and fluid, meaning that it's not going to react or it's not going to be consumed by the microorganisms present in the ambient. Bio-based, as we said before, natural ester is bio-based, opposite to mineral oil. Another important point for transformers is the oxidation stability of the fluid. Mineral oil has a good oxidation stability and is used as a reference. And in natural esters, it's a natural product, so it's recommended to be used in non-vibrating conditions. And under those conditions, the oxidation stability is equivalent to mineral oil. Of course, the aging, not only of the fluid, but also the complete transformer, it's important. And if we took again, mineral oil as the reference and stable as average, for natural esters, we will see that the aging, not only of the fluid, but the asset is much better than compared with mineral oil. Of course, everything comes with a cost. So the product itself, it's more expensive than mineral oil, but we will see some of the properties and we will see if this cost difference it's worth or not. And of course, we are talking here about the cost of the fluid itself, not the complete asset, the complete transformer, where this cost difference is diluted in the whole cost of a transformer. So just some insights about why fire point is critical and other international recognitions that the fluids complying with this high fire point have. We of course have a complete set of standards in place from IEC, IEEE, ISTM, and different standardization organisms. And also we have different recognitions as UL or FM approved fluid that reinforce the fire safety behavior of performance of these fluids. There's some numbers here. A fluid is not new. It's more than 25 years in the market, more than 3 million transformers installations, and 0 fires reported. And I would like to stress this, it's 0 fires reported, and we are talking about, what we are going to talk about in this webinar is about the effects of the different issues that the transformer may be subjected and the consequences of it. So even applying the best technology, best manufacturing process, transformers failures will happen. It can be connected with short circuit, with failures in different parts of the installations. And the transformer is going to be subjected to different stresses that will make the transformer fail, or at least work in a condition, unexpected conditions. What is important here is the mitigation of the external effects that goes from the explosion, additional fires, damage to properties and person, environmental contamination and damages. And here is what we are going to talk a little bit about the advantages that FR3 fluid brings over mineral oil. So just a short explanation how a transformer fire happens inside a transformer. As I said, any external origin of a fault can be a lightning hitting the line, issue with a short circuit in the lines, an overloading and short circuit at the end line of the factory, for example, or in a utility in a house. This creates some conditions that is going to damage the insulation inside the transformer. When this insulation is damaged, it lost momentarily the insulation properties, and an internal arc, electrical arc, is generated inside the transformer. Every arc comes with a high heat, high energy discharge, and it implies a heat release inside the transformer. It will burn paper if paper is involved, and it's going to vaporize a small amount or a bigger amount of fluid depending on the amount of energy of the arc. This vaporization is going to generate gases. And here it's when the definition and the test we spoke in the first slide comes into place. These gases that has been generated, between those gases are some that are combustible. And here, if the arc is not sustained, it's just a single arc with few milliseconds, probably the transformer is going to detect a failure, but not additional damage will happen. But if the protections are not acting as fast as needed, or there is any other problem, and the arc is sustained, the amount of gases generated will increase. It will create a break in the tank of the transformer. The gases will be released to the atmosphere, will be in contact with oxygen, and they will start burning. What happens after that, or even what happens with this, it's connected with the fire point. If we are using a dielectric fluid with a very high fire point, these gases will be released to the atmosphere, and it may burn or not, but it will be a high pressure event. If the dielectric fluid is a fluid with a low fire point, these gases will start ignite and will continue the combustion, and it will be expanded to the surroundings, damaging other equipments and with the risk for the people. And here it's we are going to focus on this, and I have a couple of videos just trying to show what are the event and the sequence of this. So here is a test performed with mineral oil. Sorry for the quality of the image. It's in a different room, in special room with a special camera, and the quality is not so good. But you can see here, this small piece is a transformer, a pole-mounted transformer single phase that is full with mineral oil, as I said, preheated fluid. This is a containment tank with also a preheated fluid on it. And this transformer is going to be subjected to a short circuit. If you look at the bottom part here, this is a disc, a rupture disc that is going to be broken after the short circuit, and you will see the vapors and the liquids flowing after the short circuit. So this is the fluid, the overpressure, and at some point when the vapors are sufficient, it starts burning. As you can see, the fire continues, and this is the typical situation that you have with a mineral oil fluid transformer when it has an internal failure. And as you see, the fire, it's also spread to the pool that it's where the transformer is installed. The same test was repeated with the transformer filled with FR3 in this case. Again, same short circuit current, very similar duration, similar arrangement, same arrangement. And as you see, and you look at the bottom part where the rupture disk is present, you are going to see the fluid and the vapors release. But you will see how now it starts, but you will see how it's even the same amount of energy has been put inside the transformer. The effect is very different. So in this case, we don't have a fire, we don't have an ignition of the vapors, and of course, we don't have a fire continuing in the heated oil that is in the pool. Of course, this is one example, but we also have other tests that has been done. So what happens if we have this short circuit inside the transformer, we have the overpressure, we have the spray out, and for some reason, there is already a fire in the surroundings of the transformer. So what is the impact of the flame in the spray? So as you can see here, the flame, when you have a flame, it's the same, basically the same arrangement, sorry. This is a warm fluid here, in this case mineral oil, with a nozzle that creates this spray, and with an external flame. As you can see, even when you remove the flame, the fire is sustained, and is that not stop? Why is this important? Because with the same arrangement, when you remove the torch in this spray, the self-extinguished behavior of the FR3 automatically remove the fire. This happens because the fire point difference. The amount of energy that is needed to bring the fluid to the temperature where it burns is much higher for FR3 than for mineral oil. So under the occurrence of the same event, the consequences are very different, as you can see on this. And if we go to an example of a real case scenario when this difference has been shown, we can see here an impact or a case that in two mine sites in South Africa that happens very close on time, and we were able to get the approval to share the images for those cases. You can see on the left side, it was a mineral oil field transformer, a small one, 100 kVA, 15 kV in the high voltage side. That had an issue on the transformer, and it creates a fire. It was not only the fire, it was a generation of smoke, cleaning. The fire event, of course, was needed to be informed and notified to the public agency. Further inspections were needed. And we are probably here talking about loss prevention, but not only the asset is important here, is the consequences of these fires. Here in this case, it was a downtime of 20 days until all the procedures were followed and all the situation was clear and ready to go again. It was a similar event with a transformer filled with natural ester. And as you can see, the result of this event, it was no fire. It was, of course, the overpressure that break the tank in some points to release the overpressure inside the tank itself. But there was no need for notification or third-party inspection on the installation required, and the downtime was only 4 hours. So here, again, coming back to the very beginning, we said that catastrophic events will still happen, but how the mitigation or the effects of these events are controlled is the main and one of the most important differences between mineral oil and natural ester here. So this is the events that happen with a transformer and the surrounding equipment itself. But it's also important to note that this has bring different requirements on the installation of the transformer. So we are not only talking about the transformer itself, but all the civil works and the equipment surrounded by that surrounds the transformer. So again, if we compare what is required for a mineral oil, and now we are talking a little bit about a higher level, a substation level, you can see that the most common installation for mineral oil, you will need a rock suppression or a rock for fire suppression for any spill of mineral oil. We will need a containment not only for individual transformers for the whole volume, but also for the rocks plus the rain, and also a second containment to make a separation between water and oil. Depending on the installations and on the national legislations, an automatic fire suppression system may be also required, depending on the installations again. If we compare this complete solution with the complete solution that is on the standards that can be put in place for a transformer filled with natural ester, we will see several advantages and savings on the installation of this type of transformers. Of course, civil works and land use are smaller, but also the fire extinguisher systems and the associated costs for the maintenance will be much smaller in this kind of solutions. At the end of the day, the only thing that you need is a small containment just for the volume of the fluid plus the rain average. And you don't need a second containment, as you can have an automatic valve that can release the water for the ambient and keep the fluid inside, making the complete installation cheaper and faster, of course. But also, this fire point and these properties brings additional benefits in the complete size of the substation. So we see that not only the distance between the transformers and the transformer to buildings are important, so you need to place firewalls just to avoid the spread of fire between the different components of the substation. And with natural esters, all this in the same ratio can be reduced. Here is just the reference standard on IC where these difference clearances, depending on the total volume of fluid, can be reduced. So this is talking a little bit about about the general differences between both transformers. And this applies, we're talking about mainly new installations for transformers. But this fluid can also be used to upgrade the existing transformers. Why I'm saying that is the retrofilling activity that is having a transformer installed with mineral oil that gives power supply to a industry, to a part of any customers. These transformers can take advantage of this fluid, even if it was not initially filled with it. And the most common reasons for the customer to perform this retrofilling activity is the first one, as we saw, reduce the fire risks and the associated costs. Also reduce the impact for potential failure. In this case, a lot of is connected with the loss of production. But also, natural esters has different properties that helps to reduce the maintenance interventions. So the downtime of the transformer to perform this maintenance, but also the cost associated to it. And it also helps the end user to extend the life of the asset and delay any further investments. This is strictly connected with other properties and how the natural esters interacts with the materials inside the transformer. But there has been a lot of retrofilling examples, a lot of retrofilling cases that has been done in the past few years for these reasons, but also for other reasons like change in the legislation, recommendations by different insurance companies that are seeing this as a benefit to reduce the risk. Again, it's a copper mine example that I like to present here. It was recommended by the insurance company, but also as a commitment of the user to operate in a more safety way. In this case, were 12 underground transformers with a power between 500 and 2000 kVA with 11 kV high voltage that were originally filled with mineral oil, and the transformer were refilled with natural ester. The transformer the process to do that is just few steps that are highlighted here. That it was flushed with natural ester between the fluid change. There was some maintenance activities also, that gasket replacement. In this case was headspace with nitrogen filled, and then additional test to evaluate that the transformer was still in good shape to be put in service, and some waiting times to make this. So going back to the fifth point of the presentation today. So FR3 not only brings these benefits for related with fire safety, but it also, as I said, it comes from a vegetable oil that it's biodegradable, is non-toxic, and bio-based. So what we were trying to see here is that sustainability is becoming a more and more important topic, and this is several tests, international recognitions, and standards that brings you the confidence that the fluid is not only fire safety, it's sustainable, bio-based, biodegradable. This is, to be honest, much more connected with the effects if there is any kind of spill and the remediation costs that are needed when you compare a natural ester with a mineral oil. So we are talking about a fluid that's going to biodegrade in a very short period of time, that is non-toxic, so it's not going to have any adverse impact in the wildlife that can be in the surroundings or in any other life. And again, it's based on a renewable source that can be infinity, let's say. It's not a limited supply of the fluid. And even in the aquatic biodegradation, this is particularly important when we are talking about hydropower plants or other installations close to lakes or rivers, and even on the sea, because it gives you an idea that even in these conditions, the fluid is going to degrade, and the aquatic toxicity also is considered as non-toxic. So how FR3 may help you to support sustainability goals is again just a bullet point of what I just said in the previous slide with the test that has been put in place to this. And at the end of the day, we need to make the sustainability goals are connected with the people, with the planet, and also connected with the profit and the, let's say, making a sustainable. There are a couple of things that we haven't covered here in this presentation, and it's mainly talking about high power density and the long life assets, because it's something that it's important, but it will require, let's say, a new webinar to discuss this kind of topics in deep. But of course, if you have any questions, please put in the chat and we will cover them later. And I would like to end this just with a very short comparison between technologies and between different approaches for this, because there is still a big concern in the industry when people think about fluid field transformers, and this is connected with fire-resistant walls, fire protection systems, contamination, spills, cleanups, and all of these concerns came from the use of mineral oil in the installations. As we saw, there are a lot of benefits when you switch from mineral oil to natural ester, not only on the fire point of view, but also on the environmental concerns. And I just make a comparison here between ester and DryType, because it is true that in the indoor installations mainly, when mineral oil with PCBs were banned, the DryType transformers, because the standard solution for this kind of applications where fire safety was a must, and there was not a suitable alternative, let's say, cost-effective alternative to replace mineral oils with PCBs. Of course, there were silicone oils and some high molecular weight liquids, but it was very limited, the expansion and the applications. So, however, since the 70s, it's fluids like natural ester, but other alternative K-class fluid has been developed and has been tackled this difference. So just to give us a short summary here, as we are talking between an FR3 field transformer and a DryType, the fire safety, it can be considered equivalent between of those, of course, depending on the specific requirements. F1 or F0 DryType transformers and natural esters with enhanced protection, you can achieve equivalent levels of safety. In general, liquid field transformers are more efficient than DryType transformers, and it's just because of the technology. The liquid field transformers allows to have smaller transformers operating in a slight different way. So the total losses and efficiency is different. It's also according to the standard, the limit losses for DryType are higher than the ones for liquid field transformer, either mineral oil or FR3 field transformers. Another point that it's important is the maintenance of the transformer itself. Whatever for DryType is a recommended activities for maintenance that involves cleaning and usually involves the disconnection of the DryType transformer from the network to perform those activities. An FR3 field transformer, there is no maintenance required. One of the key points when the fluid was developed back in the 90s was to have a fluid that was virtually maintenance free. That is, the idea of the developers of the fluid was you put the fluid inside the transformer and you forget. Of course, there is still annual checks, but it's as simple as take a sample of the fluid, make the same kind of analysis that are done in mineral oil. There are different limits because the fluids are different, of course. That is also complete refer on the proper standards of maintenance of these transformers, but there is no need for any outage for this kind of maintenance. It's also important to note that the noise also for FR3 and DryType is different, and the requirements for noise in liquid field transformers are more strict. And one point is of course the leaks. DryType does not have a fluid inside, so there is no risk of leaks. But as we saw, the effect or the impact of these leaks with natural ester is much lower than if you compare this with mineral oil. One thing that also, just to close the topic, is the comparison in the sustainability and the recyclability of both transformers. So when you have a liquid field transformers, most of the materials can be recycled. So it's the degree of circularity of this kind of transformers, it's very high, not only for metals, magnetic steel, but also for the liquid itself. However, when you go to a gas resin dry transformer, there is a lot of concerns, and it's highly energy extensive consumption to do this separation, especially when you are talking about the separation with the different resins that are surrounding the transformer. And also, it's an important part that most that the materials would be contaminated, so it can be downgraded, not being able to be used in the same application. With this, I just last slide as a conclusion is if you need to keep 4 different 4 bullet points from this presentation. Natural esters, the solution, a holistic solution for the industry from the safety point of view, low fire and environmental risks. Is a sustainable product with a carbon neutral, and it's recyclable. In terms of reliability, not only of the transformer itself, but also reducing the maintenance interventions. And of course, it's a resilient transformer because, again, we haven't touched this, but the loading capacity and the different network optimization, it's a big point and can be a very interesting point for the end user, and depending on the asset management, of course, how they want to manage. So this is my intervention. I try to keep in the schedule, Patrick. So I think this is my part here, just the highlights, and happy to hear questions from the audience.
Thank you, Roberto. Yes, and you kept to time perfectly. Thank you for that. That's very good. Thank you. So yes, we do have a few questions, and I'll try and link them back to the presentation where I can. So you gave us the example of the retrofilling on the copper mine. Is retrofilling a pretty common commonplace activity these days, particularly for the larger MVA transformers? And what are the challenges involved in that process?
Yeah. So that's a good question. So during the last, let's say, 15 years or so, it has been a lot of retrofilling activities. As I said, mainly connected with the fire risks benefits, but also with the extension of lives of the assets. It is true that for small transformers, as the ones that we saw here and what we can typically call distribution size transformers, it's pretty straightforward, the switch from one fluid to the other. When you go to higher powers, especially higher voltages, that is the most, let's say, limiting factor here. Mineral oil and natural ester have different dielectric properties. And dielectric properties, I mean the dielectric permittivity of the fluid that may impact on the design of the transformer itself. So when you go to transformers up to 160 kilovolts, 220 kilovolts, 400 kilovolts, there has been retrofills done, yes, but there was case-by-case scenario. So a deep analysis of the transformer, the insulation structure, and also additional components like the bushings needs to be done case-by-case. We typically said, and according to the experience, is transformers below 72.5 kilovolts and below 5 MVAs. The switch of fluids is quite straightforward. For higher voltages, dedicated studies needs to be done. But of course, please, if someone is thinking about a retrofilling, contact us because we have developed guidelines and we also have the different tools to perform this evaluation case by case.
Okay, brilliant. Thanks. That's very clear. Hopefully it's a more straightforward question here. Are there any limitations to the climate that these fluids can be used in, specifically reference to cold weather conditions?
Yeah, so as I said, one of the main difference between mineral and natural is the viscosity of the fluid that is higher in natural ester. And it's also true that at very low temperatures, natural esters becomes less mess and less fluid. So we said that is the consistency of an ice cream, let's say. And this puts some additional concerns on how to make the implementation of natural esters in very cold climates. I can share that there are natural ester field transformers in all climates, and so far we haven't seen any big limitation here. So temperatures down to -25 is pretty straightforward. We have made a lot of tests also, especially connected with renewables energy and wind farms, going down to -40 degrees, which is the very cold climate. And for these specific applications to these very low temperatures, there are some additional points that need to be considered in the design and in the implementation of the fluid inside the transformer. But one important thing is that even the fluid is in a not completely liquid stage, the dielectric properties are maintained. So it is safe to energize the transformer even at very low temperatures with a ice cream consistency of the fluid.
Do you get to choose the flavor of the ice cream or not?
Well, the fluid is green, so you can say it's mint.
It's mint. Yeah. Lovely. Okay. Perhaps you could help us just sort of order of magnitude on cost. Then a question here is based on a 205 litre drum. What is the difference in cost of mineral oil versus natural ester?
I don't know if my colleague Luca is here, and if he can.
Yes, can you hear me?
Give us yes, perfect,
Yes.
Luca. Thank you. Because
okay, hi everyone.
I leave money discussions for the business developers people.
Okay, you do prefer talking about ice cream rather than money. Great. So no, well, this of course, there are multiple factors, let me say, that can be considered when looking at this kind of question and answers, because it depends on the relationship and so on. But I would say that yes, there is a difference. There is almost, I would say, in a range from 30 to 40% more. But of course, we have to look at the total cost of ownership for the entire solution, right? So when we take into account the higher prices for the natural ester, of course, we need also to consider in the proper way all the benefits mentioned by Roberto and how those are really helping in reducing the maintenance costs, the civil works costs, and so on, right? So that will give us, the full picture, which is the one we have to look at, and then consider that the price and the value of the oil within the substation, within the electrical infrastructure is really, very small compared to the other parts.
Yeah.
So definitely is, I would recommend such an investment because it's the easiest and faster to be more consistent with the roadmap towards sustainability and efficiency.
Okay, thanks. Yeah, so I guess for new build applications, as you say, with those reduced upfront costs and the reduced running costs, I guess you would certainly argue it's a obvious choice, right? But in a retrofilling application, then is it possible to? And I know this is a real how long is a piece of string question, but is it possible to give a feel for how long it might take to get a payback on that retrofilling?
Oh, that's a tricky question.
Yeah, sorry.
No, because it depends a lot on different things. The first one is at which stage of the aging of the transformer is the retrofilling done, because we are also extending the life of the asset. So if the remaining time is with mineral oil is 10 years, maybe we can extend to 15, 20 years the remaining life of the assets. So all the investments are delayed, so you have additional time for make the compensation. It's always also a balance between the benefits that you bring from the insurance companies and at the end of the day a risk mitigation plan that is put into place. So it's not a quite a straightforward way to answer this.
Okay, no problem. Okay. So another question here. Do the fluids with different flame point also distinguish in their fire extinguishing behavior? Does higher flame point also result in faster extinguishing?
Yeah, there are several factors that are, let's say, there are several factors that are involved in this process. So you have the higher the fire point is, the more energy you need to continue burning the fluid. So yes, this is the predominant and let's say the most important parameter to evaluate. There are other parameters that also influence this behavior. That is the amount of energy that the fluid releases when it burns, right? The higher the energy it releases, more fluid is going to hit. And a second one, it's a little bit connected on how the fluid is spread when you have this, especially in the test that we saw with the spray, right? It's how it spread on that. But and this is a test also done by 35 entities that the most important parameter should be the fire point, or at least it is stated.
Okay, thank you. Next one here is FM Global do not differentiate between liquid/dissolved gas testing of transformer fluids. Is this correct, or is less frequent testing permissible for natural ester fluid?
I'm not sure if I understood the question properly. So the FM Global doesn't differentiate liquid. So I can explain what FM defines on the testing. So FM firstly qualifies fluids, and it's approved fluid based on FM. And this is the fluid is subjected to a series of tests. And then there is a second step, that is a transformer that is FM approved. That it's involve additional protection requirements connected with the transformer itself. So one of the conditions, of course, is to have a fluid inside that is FM approved, but the transformer itself needs to comply with additional requirements. I don't know if I have answered the question or if it was.
I'm not sure if Patrick is there.
I don't know, we have lost him.
Yeah. Okay. While he's disappeared, I'll just read the next question. Is there a size limitation, MVA, for new transformers? For example, can natural ester be used in a large transformer for an electric arc furnace?
Yes. So if there is any size limitation for transformers, the answer is no. And just to give you some ideas or reference, transformers filled with FR3. Here in Europe, for example, we have several transformers above that is 400 MVA installed in the networks. One in Germany, for example, we have 375 MVA installed in Italian network. In terms of power, in terms of voltage, the highest transformer tested with FR3 highest voltage was 750 kilovolts. So again, it's not a limitation on voltage. And regarding application, for example, electric arc furnace transformers and so on, there is no limitations on the application itself. It's just a matter of designing the transformer according with natural ester properties that, yeah, most of the transformer manufacturers are able to do.
Okay, thanks. And I see it looks like we've got one more, or two more really. One you've already kind of mentioned. Is there any transformer age restriction to retrofilling? What should the maximum age of transformer to be considered for retrofilling?
Well, yeah, not an easy question to answer, but let's say that, of course, what's important here is it's not so important the age of the transformer, but the expected remaining life of the transformer. So for this to make, if there is no any other request regarding fire safety and so on, and the idea is to extend the life of the asset with the retrofilling, which is important is the remaining life of the transformer. So if the transformer has 2 or 3 years expected remaining life, it's most likely that it's not a cost-effective solution. We are not going to extend the life another 10 years, okay? So we typically advise the customers that the sooner the better. But of course, if the remaining life is 10, 20 years, 15 years, it's a very good opportunity to make the retrofilling. That's for sure.
Okay, thanks. I think we've got Patrick back on, but we're just trying to sort out his mic. Anyway, last question. Are there any of the sealing materials, for example, gaskets, O0 rings, affected by ester oils for retrofills?
Okay, so yeah. So it's an important one. So when a retrofilling is made, and our recommendation is to change the gaskets, not because they are going to be affected by, let's say, not just going to be affected by the ester itself, but because when you make a retrofilling activity, you release the tank, change some changes in the active part, and the gaskets lose the properties, the mechanical properties. So it's our advice, our recommendation, I would say almost mandatory, but we are not the owners. So our recommendation is to change the gasket to avoid any potential leakage of the transformer. Now, if we talk about compatibility itself, the set recommendations that apply to mineral oil feed transformers apply to natural ester feed transformers. So if you are using NBR or rings, it's the same material with a nitrile content higher than 33%. That is the most common solution for mineral oil. It's also valid for FR3 feed transformers.
Hi, I'm back. I'm back. Sorry about that.
Okay.
There's some sort of total failure of my system, but no ensuing fire, so that's good. Apologies. Thank you, Stephanie, for taking over in my absence. I think we've got one last question, which is my chance to come back to the question that everything failed on before. So somebody's trying to clarify and I don't know where you got to with the previous question. Apologies, but the comment is, I think Chris's question was about the frequency of DGA sampling, whether it's the same for natural ester. So that was the earlier question around less frequent testing being permissible for natural ester fluid.
No, the testing and this is the testing of the transformer and the fluid itself on the standards, on IC and IEEE standards for maintenance of transformers. Some guidelines are given about the frequency of oil sampling, DGA, and so on. But there is a very important remark on the standards, that is the user needs to define the proper and the suitable testing periods. And this is important because on the standards, we define the transformers based on the size, the power, and the voltage. And we recommend different maintenance schedules. 1 to 3 years, 5 to 10 years, 5 to 7 years, and so on and so on. But at the end of the day, what defines this is how important is the transformer for you, for the end user. So if you have a small transformer, a distribution transformer, but it's supplying your mine, your factory, for you, this transformer is the most important one. And in the standard, it says that you can make samples every 3 to 5 years, but you would like to make samples every year because you want to be sure that this transformer does not fail. So the testing, sampling, and the maintenance activity is much more connected with the importance of the asset than with what is inside the asset.
Okay, thank you. Hopefully that's clarified that. But please, any of those two question raisers want to come back on that, please do. Another one here, which is now way outside my comfort zone, so I'm just going to read it out to you, I'm afraid. Will there be any impact on the Buchholz relay function?
Okay, so usually, and as far as I know, all the Buchholz relay that are available in the industry are suitable to work with the different fluids. So even if you have very fast oil displacement, gas displacement that goes through the pipe to the conservator, or if you have a low level of oil going down to the pipe, reaching the Buchholz relay, Buchholz relays has been tested to be used with different fluids. So there should be no difference in the behavior and in the sensitivity of the fluid itself.
Okay, thank you. Right, this one just popped in, appears to be a statement, I think, rather than a question. There are different IEEE standards for DGA of mineral oil and ester oil filled transformers.
Yeah, so important point. Thanks for the question. So DGA is a suitable tool to be used with mineral oil and with esters. But as we saw, the fluids are different in nature. So under the same event, they are going to generate the same gases, but in different proportions. So the way you analyze the gases in mineral oil and in esters will be the same tools, but it will change slightly the interpretation of those gases. And yes, on IEEE, there are two different standards for DGA, one for mineral, another for esters. In IEC, there is one for mineral, we are working in the one for esters. We had a meeting a couple of weeks ago, just trying to finalize the written of the standard itself, and it will be probably published next year.
Okay. Thanks for the clarification. Good. Well, that's currently the end of the questions that we've got in the chat. Unless there's anybody else out there typing away.
Looks like that's it for now.
I think so. I guess we can offer that if anyone has any further questions and wants to email them to us, we'll happily pass them on to you, Roberto, if you're willing to field those for us.
Absolutely. Just
Good.
I will put also our contacts on the presentation that's going to be uploaded. So if anyone has any doubt, please, feel free to reach us directly or through EMEA. It's
great.
It will be good to hear from you.
Good. Okay. Well then, Stephanie, unless there's any other EMEA business, do you want me to bring things to a close?
Yes, please. Nothing more from my side.
Great. Thank you. Okay. Then all I'll do is just thank you again, Roberto, and obviously Luca, for putting that presentation together and just EMEA webinar. Thank you for joining us. And also thanks to the guys at Cargill Bioindustrial for offering this topic today.